Question number 2, we have to work out the final speed of an object. We're given a graph. The graph looks, I guess, a little bit like this. It's got a kind of step to it, kind of similar to that, and it's a force time graph. And all we have to do really is calculate the change in momentum for this thing, because we know the mass, and we also know the initial speed of the object. It's going from rest. You hopefully will remember that the area under the force time graph always gives us the change in momentum. So if we work out the area of this shaded area here, that will tell us the change in momentum. The reason that's the case is that force is defined as the rate of change of momentum, delta mv over delta t. So if we rearrange that, we can get F delta t is equal to mv, or delta mv. So this force times time thing, this is reminding us that we're working out the area under this graph. It comes up in two very easy stages, because you've got 0.5 seconds here, you've got 1 second here. So all we need to do is multiply the width by the height of both of these rectangles. The first one here has got a width of 0.5 seconds, it's got a height of 5, it's going to be 0.5, like this here, F delta t is equal to 0.5 multiplied by the height of the thing, which is 5. That's of course going to give us 2.5, and add that to the second area here, which again has got a width of 0.5 and a height this time of 15. So it's 0.5 times 15 for this second area. If we add those together, we end up with 2.5 plus 7.5, which of course is going to give us 10. So we've got a rate of change of 10. That would be 10 Newton seconds from force times distance, or it would be 10 kilogram meters per second, because it's also in units of change of momentum. So we know the change of momentum of this object, and it makes it nice and easy because we know the mass of the thing as well. We're told the mass is 2 kilograms, and we know that the initial speed is 0 as well, so that makes it nice and easy. We know that the momentum equation, P is equal to mv. So if we're trying to work out the change in velocity, it's going to be the momentum divided by the mass. The momentum change we said was 10, the mass is 2, and so it's going to give us 5. So that's going to be the change in velocity. It's going to be 5 meters per second, and of course because the initial velocity was 0, then the final velocity with a change of 5 is going to need to be 5 meters per second, so that's going to be answer B.